Okay, hello everyone. We are going to work on a bit of Module 1 work. Now, this particular recording is being done after students have had time to engage in the sequence and series module a bit. So we're not going to go right back to stage 1. We're going to try to pick up on some of the harder questions, shall we say. Couple of little things to talk about in terms of the formulas that are on the formula sheet. On the formula sheet, when you see T1, you may, if you Google search or watching some videos elsewhere, you might see that they use the letter A in reference to term 1. In fact, I fall into that all the time because in years past, up until like the last 10 years, A was always term 1. So if I fall back into that, you can correct me and I'll try to put the other formula up. And then within sequence and series, in terms of just doing kind of a little overview, we generally look at kind of 3 parts. We look at arithmetic sequences and series. And we'll do, like I say, just kind of a brief overview, but then we're going to get into some questions that I think are kind of the challenge questions. Arithmetic, the word indicates that we add or subtract to get from term to term. And the word sequence means that it's a list of the terms. And the word series is that we add all the terms. Okay, so all of those words. We're talking about sequences of numbers, like patterns of numbers. And when they're arithmetic, we add or subtract to get from term to term. If we just have a list, it's a sequence. And if we're adding them all together, it's a series. So with that in mind, let's do an arithmetic question, and then we'll change and we'll do a geometric one. And then there's a little bit of infinite sequence and series we'll talk about as well. So this question is similar to one on the Module 1 Lesson 2 quiz. So it's not the one on the quiz, but it is similar to it. I think I might have snagged this out of the textbook, to be quite honest, but that's fine. So it says, find X in the following if it's designated to be an arithmetic sequence. Okay, so find X in the following if these are terms in an arithmetic sequence. Sorry, my penmanship's not the best on the board. And the terms are X plus 13 as term 1. And then 24 minus X. And then the last term is 20 plus 2X. Now, again, if you're here or you're watching this recording after the fact, do note this question. There is one on lesson quiz, and I believe there is one on the module test, actually. So I'm trying to kind of do some of the highlights. So we look at this, and it looks pretty tough, kind of, I would think. So we can start and do this. We can say term 1 is that guy, term 2 is this guy, and term 3 is this guy. But something good to note, if we just go to the side for a second and I do an easier arithmetic sequence to point something out that I'm sure you would know. If we had 2 and then 6 and then 10 and then 14, and I asked you to find D, which is the common difference, I would hazard to say we would barely have to put any brain power to that, and you would see that it was 4 that we were adding. However, if we really wanted to formalize it, and I said, please show your work, well, not really much work to show, but 6 take away 2 would be 4, or 10 take away 6 would be 4. Now, the important reason I show this is that if we don't know the actual values of the terms, but we know that we've got term 1, term 2, and term 3, we can find an expression for the difference by going term 2, take away term 1. That's exactly what this guy here is showing for an easy arithmetic sequence. We also can find the value of D by going term 3, take away term 2, which is what this guy is showing. Now, that gives rise to a little formula. Now, this formula is not on the formula sheet. So if you are taking notes and or you want to have a little bit of help in terms of getting prepped for how you go through the online course, I suggest every single module you do your own formula sheet. Okay, get a piece of paper, ask your coordinator or mom, dad, wherever you work for a nice colored piece of paper or something, and then write down module 1 and write down any little formulas that you find are not on the formula sheet that would be helpful to study. You can't use that on your test, but you sure can have it up and look at it quickly and study it and put it away and go to your test and write it back down on a piece of paper. That's totally fine. So here it gives rise to this formula. Term 2 take away term 1 is equal to term 3 take away term 2. And that little formula is very, very helpful for arithmetic sequences. So for those that are here in class, I'm going to give you a moment to put the expression of term 2 into the T2s, the expression for term 1 into T1, and T3 to T3. Try to solve for X for me. We'll do a little pause here. Anyone that's watching the recording, work away on it until you hear me talk again. Okay, so let's look at the solution to this. So thank you very much for interjecting those that are here. So we get 24 take away X. I would sub in brackets just to be careful and then take the brackets out if they're not useful. But in some cases, we're going to have to watch the minus sign. So we get minus X plus 13, and then we get 20 plus 2X take away 24 minus X. So we have to be a little cautious about these minus signs. We think of it as -1 out front, and then we distribute the negative, and a -1 out front, and we distribute the negative. So we have to be a little cautious. So here's what it looks like. Check your work. 20 plus 2x minus 24 plus x, being careful that those second one change sign. So let's collect some terms. We've got 11 minus 2x on this side. We've got -4 plus 3x on that side. So it doesn't matter which side we move things to. I'll just take the x's to the left-hand side, subtract 3x, we get 11, take away 5x is equal to -4. And then we're going to subtract 11 minus 5x equals -15. Divide by -5, get x is equal to 3. And that's what we were asked for if we take a quick little peek up, find x. Now be careful, there is a question somewhere along the line, might be giving the test away, don't know, where it says find the values of term 1, term 2, term 3. So if we were asked to then find the values of term 1, term 2, and term 3, so if that was kind of, you know, to finish off, be cautious that you put x back into the expressions, right? So term 1 was x plus 13. So it'd be 5 plus 13 or 18, and so on and so forth. Term 2 was 24 minus x. So we put it in there. We get 24 minus 3, 21. Looks like our difference is 3 here. And term 3 is 20 plus 2x. So we get 20 plus 2 times 3 is 26. Does that work? 20 plus 2x, 20 minus. Okay, that doesn't seem to quite work. 20 times. So we have a difference of 3, and then we have a difference of 5. Oh, isn't that very interesting? Anyone in the class see what I might have done wrong there? Let me pause for a second. So I did just take that question from the textbook. So that's very interesting. They didn't ask us to find the terms. I just thought it would be a nice, really logical thing to do. It doesn't seem like the expressions that they kind of worked out, so our x value would turn out to be kind of cool. Seem to work unless I'm really just losing my mind. Term 1 is 16. Why is term 1 16? It's x plus 13. X. Oh, haha, look at that. Thank you very much, Jacob. Okay, so I put 5 in here for some odd reason. I'm just losing it. Okay, good, 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 good. Let's just quickly fix that. Thank you very much. Sometimes when I'm putting things up on the board, I don't really see my little mistakes. So I put a 5 in there for some reason. Okay, so there's good. So they didn't give us something that was wacky. There's our numbers there. Okay, so again, just a brief look at some arithmetic sequence question that comes up. I want to go and look at an arithmetic, a geometric sequence and series question that's sort of the same. The math gets a little bit tougher. So the second thing that you study here is geometric sequences and series. Sequence and series. Okay, so what is difference between, I don't like my sequence there. What's difference between arithmetic and geometric is that we multiply to get from term to term. And now we might multiply by a fraction. So you sort of think of dividing, but I always just say you multiply by a whole number or you multiply by a fraction. Easier to think of. These words mean the same thing. This is a list of the terms. And this is a sum of the terms. And there are various formulas that you can look up for the different questions. Okay. All right. So then when we look at a question, I've got one here. So kind of the same thing. I don't know for sure if this one is on the quiz or not, but the question is the following. Let me write it down and then I can transcribe it up here. And it reads kind of the same as the last one. Find x if x plus 2, 2x plus 1, and 4x minus 3 are the first 3 terms in a geometric sequence. Okay, so geometric sequence. We're multiplying to get from term to term. Again, hopefully it was helpful to kind of look at an easier one here. So let's say that we have 2, and then we have 6, and then we have 18, and then we have 54. So we're multiplying to get from term to term. So if we were going to try to find the R value, that's the ratio. That's the letter we use when we're talking about geometric sequences. 6 divided by 2, the number would be 3. If we wanted to find R a different way, 18 divided by 6 would be 3. Better get the same answer, right? Divide a term by the term before it. So again, gives rise to a little formula that you might want to throw in your formula sheet. R value can be found by term 2 divided by term 1, or the R value can be found by term 3 divided by term 2. Dividing this time, not subtracting. And so then you get term 2 over term 1 is equal to term 3 over term 2. So for those that are here, blast off into that one, see if you can find the X value, and then send me a quick little message. I'm going to go pull up the next question that I want to look at with you. So I'm going to leave my audio off. I'm just going to start to work on the board. So those that are working on it, if you want to glance up here, fine. I'll go through it in a minute. If you're still working, totally fine as well. Okay, so I think I better explain as I'm going now. I've got term 2 in there and term 1. Like I've got my equation kind of figured out what goes where. And so we're going to look at how we would solve this. So I have little arrows there to indicate that we're cross multiplying. And so we're going to get 2x plus 1 multiplied by 2x plus 1 equals 4x minus 3 times x plus 2. So really cranked up in terms of difficulty what we did a minute ago. Now the expectation is that, remember, FOIL, right? So we are in, the higher level math here. Hopefully we remember how to do this, but I'm happy to show you. So this becomes 4x squared plus 2x plus 2x plus 1. And then we get 4x squared plus 8x minus 3x minus 6. Now, lucky for us, the 4x squareds on both sides cancel, which is beautiful. And so we can collect like terms. We get 4x plus 1 and 5x minus 6. And so, if we want to make our life easy, we could move the x's to the right-hand side and get a positive 1. So let's do that. Let's be wise about it. So let's take that over there. We get 1 equals x minus 6. Add 6 to both sides, and then get x equals 7. At the end, I sort of move it around. Okay. And again, like a minute ago, we could go and put the 7 into the expressions. And as long as you don't make any silly mistakes like I did a minute ago, then it'll move in there, no problem. Okay, so to recap, we've looked at just a little bit briefly an arithmetic sequence and series question and a geometric one. There was a request to do kind of a harder application. So I did, while you guys were busy working away like busy little beavers, I went and grabbed it, and it's actually nicely typed. So I'll just get rid of my work from my last class that I have in here. Get a bit of a more clean space here, and I'll throw it up here. And we can have a little thought about it, and then we can talk about it. Okay. Whoops. All right. So it should come up nice and clearly on the board. And it's not as big as I'd like, so I'm just going to kind of make it a little bit bigger. Hopefully that's okay. If you are here and you can't read that, let me know if it's too small. It says the first 6 terms in an arithmetic sequence are plotted on a grid. The coordinates of 2 points on the graph are 3, 11 and 6, 23. What is an expression for the general term of the sequence? Okay, so really very different application than what we have done to date in our session together. Now, I would like to open it up to the students that are here. Remember that if you decide you want to come on the audio, that your name will show up. What I could do is, what I will do here, because your names are right now not showing up because you're not chatting, is I will rename you so your last name does not show up. It's your first name and then just your last initial. And then if you would like to speak up and be involved, I would love that. It's much nicer. So I'm just going to do that to you. So does anyone have any suggestions? Would anyone like to come on the audio and give me a suggestion as to how we can lay out this information that we've got 6 terms in an arithmetic sequence, they're plotted, and we've got 2 points, and somehow we're supposed to find an expression for the general term. Anyone want to jump in? Don't feel you have to, but I'd love to hear from one of you. Okay, no takers, totally cool, no pressure. I'm not ever going to ask you here to put any pressure on you. Let's write down a few formulas, see what we might do. My suggestion when you get hit with a really unique question is start getting formulas down, start figuring out, okay, which formula is it, first of all, and then how could I put this information into the formulas? So a couple of key things here. It does tell us that this is an arithmetic sequence, super, super important. So go to your formula sheet and pick up the arithmetic sequence formula, and it's term 1 plus n minus 1 times d. So that is really, really a great starting spot here when it talks about an arithmetic sequence. Then the coordinates, it tells us 3, 11. Okay. What that is telling us is that this is the 3rd term, so therefore n is 3, and this is the value of the 3rd term. Therefore, this is Tn, or term 3. So we can put this in the formula as 11 equals term 1 plus n minus, plus 3 minus 1 times d. Or this could simplify as 11 equals term 1 plus 2d. So not enough information yet to proceed to find any answers, but we have not used this piece of information. So again, this is saying that n is the 6th term, and this is telling us that the value of the 6th term is 23. So we go 23 equals term 1 plus bracket 6 minus 1 times d. 23 equals term 1 plus 5d. So we now have one formula and another formula. Now, something I do need to ask the students that are here, you may or may not remember from last year, because with COVID, we may have had trouble. Does anyone know, did you guys do linear systems last year? Where, so I can give you some terminology, you just quickly type to me yes or no. What you would do is you learned how to either do them by substitution, you might have done some graphing, you might have done adding and subtracting. Any of that ring a bell for the 3 of you that are here? Just in the little chat bubble, just type to me and say, yes, we kind of did this, or no, I have no idea what you're talking about. It'll guide me a little bit in terms of how we did it, how we do it. Okay, so fair enough. We're not really quite sure because it was during lockdown. So I will show you what you can do with these ones. These don't get overly difficult. So if you did it last year, great. If you didn't, I think I can hook you in, no problem. Let's line these up. Let's call this guy equation 1 and call this guy equation 2. And I'm going to put them one above the other. So there's equation 1 with a circle around it. And that's how I usually identify equation numbers. And there's number 2. Now, something really cool happens when we deal with two equations like this. If we can line them up and add or subtract them so that one variable disappears, we can do a series of solving to find both answers. So if I subtract these, I get 11 take away 23 is minus 12. Term 1 take away term 1, cool, disappears. And 2 take away 5d is minus 3d. So what I'm doing is subtracting, right? 11 take away 23. These guys cancel and these guys subtract. And then nice, that's manageable. Divide by minus 3, you get a difference of 4. Excellent. Now we have to go back and find term 1. We can use either of those equations, equation 1 or equation 2, or we could use both to make sure that the term 1 value turns out to be the same. Doesn't matter. So I usually ask students to write down what they're doing. So sub d equals 4, say into equation 1, and with the circle around it, I know that I'm talking about equation 1. So write down equation 1, 11 equals term 1 plus 2d. Put the d value in, 11 equals term 1 plus 2 times 8. Now things are looking, 2 times 8, Lord. I'm really bad with the substitution today. 2 times 4, I'm doing the multiplication before. So we get 2 times 4 is 8, take away 8. So we get term 1 to equal 3. Okay, so now we have to go back and revisit the question, see what they actually asked us. We do know d, and we do know term 1. I don't think that's exactly what was asked of us, but there's some information that we know. Let's go back and read. It says, what is the expression for the general term of the sequence? General term of the sequence. The general term of a sequence means kind of like a formula, okay? So the general term. What we're wanting for a general term, I'm just going to get rid of some more work that I worked on with my calculus kids here. Get rid of this. Okay, so the general term, what we try to do is put as much information into the formula as we can. So we'll go back to the irregular formula of an arithmetic sequence, and we can insert term 1 because we know it, and we can insert d because we know it. So we get Tn equals 3 plus n minus 1 times 4, and we would want to simplify that a little bit. So multiply the 4 through. Tn equals 3 plus 4n minus 4, and then our final simplified answer, maybe 4n minus 1, maybe put the 1 at the end, doesn't really matter, minus 1 plus 4. And that would be an expression for the general term. Now, if anyone has any questions, please feel free to either come on the audio or type a question. If you want me to go through it again slowly, I'm happy to do that. If you're all good, that's great as well. So maybe give me some feedback in the chat bubble as to whether we want to go back through it or if we're okay to go on. I have one more question I want to talk with you guys about. Okay, awesome. Now, again, the little bonus of being able to come, and I know that that's maybe not fair because some people just don't have the class schedule at this moment in time. But if you watch these recordings, I'm trying to make them as useful as possible for your assessment pieces that you have to do in the class. Let's talk about a handshake problem. It's kind of cool. Now, people that are watching the recording don't know, but there's me and 3 students here. Okay, so there's Mrs. V, and without revealing any details, there's student 1, there's student 2, and there's student 3. So let's say that we could electronically shake hands, okay? Or let's say we were, yeah, no, we better say with shaking hands. Saying hi, that's a little bit different thing. So let's say that I want to electronically shake hands with the 3 students. So I'm just going to use V for me, and then 1 for this, and 2 for this, and 3 for this, just to make it easy. So I would step up, and V would shake hands with 1 and 2 and 3. And so in the first kind of round, there'd be 3 handshakes, and I would have shaken hands electronically or said hi to these 3 students. And in reciprocation, at the same time that I shake their hand, they shake my hand. Then we could turn to student 1. So none of the students have really said hi to each other. So then we could have student 1 say, hey, hi, student 2. Hi, student 3. And that would be considered the second round, and there'd be 2 handshakes in that round. And then now student 1 is shaking hands with me and with the other students. I'm done, they're done. And then student 2 would turn to student 3. There'd be 1 handshake in that round, and then they would have said hello. So when we have 4 people in our little situation that I have, a way of describing the handshakes that would happen would be 3 in the first round, 2 in the second round, 1 in the third round, for a total of 6. So that little idea is helpful. I think it's question 6 on the assignment, 5 or 6, I can't remember which number, not the first one, but one of the questions on the assignment has to do with handshakes. It doesn't have the same number of people, but that idea might help you along in terms of doing that question. So that wraps up what I wanted to talk about on sequence and series. So we will finish the recording at this point in time.